Like this is way better for that, because now you can have all of those different signature, all of those different verifying circuits for different signature algorithms, all allow you to put a new secret in this semaphore group, and then you prove the same. And so in the end, if you have if you forget about timing attacks and you start from the assumption that like there will be some delay between the registration and the use, there's no way to know when you do an action which signature algorithm your passport has, right?
I think it's, you mean like a timing attack, right?
Yeah, so the problem here, and this is one thing that we want to talk about and try to solve, is the timing attack thing, which is basically that if you come with your passport and you want to mint an identity right now, and you want to do a vote right now, how do you make sure that you're not, because if you just register the identity and use it at the same time, then in fact, in reality, you're going to link the nullifier of the passport.
This problem was that
but it depends on how you compute the nullifier.
Yes.
In our case, for example, we got rid of because we at the last version we had two nullifiers. One which were computed from name, date of birth, etc. But we got rid of it because you can reinforce it.
Yeah.
So that's why we wanted to have a nullifier which have some flaws, because, for example, we are not sure how to handle the change of the photo bytes.
Yeah.
So this nullifier could have a short life, let's say 2 to 4 weeks, for example, because it's around the barely the time that it takes to change your photo in your other ID. But yeah, we wanted to avoid that, so that's why we changed.
Because if it's 2 weeks or 4 weeks or something, then either people can create new identities, or you have to have everybody re-register every 2 or 4 weeks if they want to do an action. Because you want to change the tree.
But that is something that we can. So, for example, the state of the underlying data to generate the proof is something that you can store easily. So you can have a PDF of your previous identity. So we can really one circuit where you need to show that a commitment of the previous photo, and so you can compute the previous nullifier, and then you show your new nullifier from a newly signed data, and as we are outputting the timestamp of the signature, you can you can have a recovery easily, just a recovery method.
You can recover, but if you want to register a new one, you can do it, and you don't have to bring the previous one, right?
So you register a new one.
A new identity.
In this protocol?
Yes.
But in this protocol, so this is your identity, and so you can think about so having a starting dot, and then on top of that we'll have a proof of personhood. But this is managed by the smart contract. So the smart contract will store your nullifier.
Yeah.
So in the smart contract you can have a custom method that for recovery.
I don't mean how to recover. I mean if your photo changes, a month after or something, you can now register a new identity, and there's no way to remove the previous one, right?
Yeah, but you can do that. But if that works, and you have a bunch of so you will have no incentive to create a new identity, because everything will be linked to your previous identity.
Definitely. I completely agree. There's no way around it if things change.
Yeah. It's you have you have a new idea and you want to change Google account, or it's not really linked, but I don't. So you have a good stage in the game to just change.
Yeah.
But just wanted to because I thought that there is a lot of differences from Totem, and my main goal of the discussion was mainly highlight and understand if we miss something here, or if there are holes in the process.
I think there's no holes. I think this is really similar to what we're going to do, but this does not include the totem part, and so I can just do a whiteboard on totem. And I think it's distinct and can be done with it. This is very also similar to what we're going to do with the passports, even without totem. Because we have basically the same situation as you with the passports. I guess then the main things we might talk about is timing attacks, because timing attacks are going to be a huge thing for us, I think.
But it's only a problem if you are joining a group and then
doing the action at the same time.
Yeah.
But this is very common, unfortunately. Like, if you want to do a vote, like, you don't want to register before and then come back or something. And so then, like, the solution might be something like sometimes you send, like, your group to do the action to, like, your server or something. They will wait some time and then send it.
Yeah, I mean, it could be also handled on from the, like, let's say you have an app and then the app says you join, like, you can vote after 1 hour, for example.
Yeah, but then, like, if you close the app and you don't open it again, what happens? You have a liveliness assumption in the app, right?
Yes. Yeah, but that's okay.
Well, that's okay. Like, for instance, if you vote in an election or something, you may just...
No, you don't vote. You ask the person to come back and vote after something.
Yeah.
You can. It's not great, but
it's...
But yeah. Like, we have some other problems here, I think, because
okay.
Like, if you join, you get the proof of other and then join the one group for, but basically that's for Indian residents. So if you're in that group, it means you're an Indian resident. But you also join age above 18 group. You also join a group of your gender and your state, for example. So you are joining multiple groups, and let's say an app wants you to prove that you are from one particular region, okay? So, and you are above 18, so you have to produce two semaphore groups. So yeah, so the more number of attributes that the application wants, the more number of pulls you have to do.
Yeah, you can also just do one semaphore group with all of this,
yeah,
and
so
avoid having multiple, and then do selective disclosure on the
leaf. Yeah.
On the leaf,
so,
yeah. This is in Totem too.
Oh, okay, you have to.
Yeah.
That's what we were discussing before. So,
yeah.
Like maybe one group, and then the first level is the attribute IDs or like attribute names, and then you reveal that.
Yeah, like basically, like in the leaf, you have one of the components of the leaf is a hash of all of the things you can disclose from the attestation.
Yeah.
And so in the end, when you do a proof of inclusion of this leaf in the semaphore group, you can reveal specifically some things.
Yeah, but how do you conclude this leaf? Like, what prevents me like to register fake information inside this leaf?
Well, when you register, this is checked in the first part when you register your identity with the attestation.
Yeah, but so how do you? Because okay, so I get it. So I need to commit to a leaf, but I guess that I need also like to prove the data that I am sending to the leaf, and I also need to give like a kind of identifier at this moment. So what is preventing like from linking all this information, because you have one step when you need to write it somewhere. So what is preventing someone to retrieve this information?
To retrieve what exactly?
So you will have like
your
an
private
identifier, because I need to identify and say, okay, that's...
Like a semaphore secret?
No, I don't know. Like, it's my question on Totem, because it's not like, for example, Totem is not like mentioning any semaphore ID or whatever. So that's my question. So what is exactly the process, and when it's happening? Like, is it like on a server? Is it like on a smart contract? And what is exactly the method of writing data to this leaf and like retrieving data to this leaf?
Okay, yeah, I can show that. I'll just just turn that around.
You can use the second one.
Yeah, I'll just use the second one. Can I remove that?
Yeah.
So basically, Totem is quite similar to what you described. I guess the main difference is that we are going to put the data that we want to disclose in the leaf. We are also, just like in Semaphore, going to register a secret. Now we're going to have this big tree with all of the attestations. And in each leaf, there will also be the attestation ID, which can be like Ketchak of passport or Ketchak of Ananada or whatever you want. It's just a unique identifier of the ID type. And then the nice thing about that is that if you want to like build a system like Bitcoin Passport on top of it, you can compute a score, or you can like compute similarities between things without revealing like much things. So basically, just like in what you just saw, there are two steps. The first step is registration in the tree. So you have to prove that you have, for instance, a valid passport. or valid another or whatever you want. And you will like prove, you know what, maybe I'll just look at my graphs because I think they were better. Yeah.
That's nice. Is it like you that made this?
Yeah, we did that.
That's amazing.
Yeah, we can do one for another too. Would be lit.
Oh really?
Would be literally lit.
Yeah.
In the literal sense. So first you register. So basically when you register, you bring this proof that you have a valid attestation, and it's going to be checked by the circuit, of course. And you bring this secret and you add this leaf to the Merkle tree.
So I guess yeah, you need to show to verify the proof.
Yes, exactly. And so the leaf is attestation ID.
Okay, so attestation ID is like a protocol identifier. So in this case, it would be like a proof of passport identifier.
Exactly. So the secret is the semaphore secret. It's just a random number.
Okay, so it's an identity commitment.
The attestation ID is like it can be 1, 2, 3, 4, 5 if you want, but it can be like get track of passport or something.
Okay.
In practice, it would be, for us for instance, it would be like get track of passport and then the signature algorithm, because we will have different verifiers for each signature algorithm.
Or even the country, I guess. Yeah.
So the country is going to be in the data. So in the data, basically, I call it data, I don't have a good name for it, I call it attestation data or something. So it's basically a hash of all of the data that you might want to reveal later. So for instance, in our case, there is like the MRZ. So the MRZ is like the big string that contains all of the data of the person. So there is the country, and a few things are not in the MRZ, for instance, DG2, which is the photo, so like the photo. Anything you might want to reveal later. So this is all in your commitments.
So is the tree, is it like one tree for one person?
So for one person? No, for everybody.
It's just one tree, right?
It's one tree for every attestation, everybody. Yeah.
So that's like because because there is two kind of trees. So you have like the protocol or attestation tree, and then you have like one bigger tree where you commit like all these attestation.
No, there's only one tree.
Oh yeah, maybe I was asking about the subtree. So okay, so that's me, the last one, okay? That's my passport, for example.
Yeah.
Okay, where would my Aadhaar go?
Oh, your Aadhaar, you can just register a new one and it will go there, or the next one.
It could be like anybody's Aadhaar as well. Like
Yeah, it could be anybody's Aadhaar, yes.
But wait, like because is it like something that you want to do like on chain or off chain?
You can do it on chain or off chain. I think when I think about it on chain.
Because how do you add new kind of attestation in this case?
So
because you will need like to enter the microtree, you will need to verify the underlying attestation.
Yes, exactly.
So how do you add like in your smart contract? Okay, so having incremental. So let's say like you have like all these proofs, and then 1 month later you have like 3 protocols that want to join.
Yeah.
How
so
do you add them?
as a developer, you can come and say, I'm going to add this new attestation. This is the attestation ID. It's get track of I choose those people. Like you can just create an arbitrary thing, and this is my verifier, and it can be a verifier for like a real world attestation. It can just be you arbitrarily putting addresses if you want to, and there's no discrimination in the sense that it's all going to be like added in the same tree. But then the nice thing is that applications, when they consume this, they are going to be able to choose which attestations they consider valid for their application by choosing attestation IDs. Is it clear or not? Like, yeah.
So I have another question. So this tree is on chain, right?
Yes.
And to add a leaf to this tree, the smart contract functions verify this attestation is like verify by calling the attestations verifier and passing the data. Is it?
Yes, exactly.
Okay, so
The verifier contract, like POSIX in
and yeah, and so to add the number you need to have this number public key. So
Semaphore public key.
identity number.
Yes, you need to have
Yeah.
a valid attestation. Like
So what is that delta?
the data is
No, the delta.
The secret, I think.
the S is
Also
the
the value
secret.
is hash of all of this.
Yeah, the commitment, the hash of all of this. I think in Semaphore originally, the commitment is just hash of secret and like group ID or something.
Oh, it's just the hash of the public key.
It's hash of the.
What do you call the public key?
So now you know since before it's like semaphore is built on top of DNS. So you have like you derive from.
Oh.
No, even before it was.
Yeah, but before it was like derived from a secret. It was hash of a secret, but now it's like
What?
like
Still hash of the secret. Earlier
Why
there
do you
were
need a
like two-
public key in Semaphore?
You need like so your leaf is basically a hash of your public key, and then when you prove that you are a member, you are basically proving the ownership of a private key whose hash, like to which you can produce a Merkle proof of the hash.
Yeah,
Something
but
like that.
this is basically similar to just having a secret and storing like Tornado Cache or like.
Yeah, I want
Like-
to like yeah you can
For instance, in Tornado, which is basically before Semaphore, but it's like the same thing, you come with these secrets, and the only thing you reveal is the hash of the secret, and then
Yeah.
when you come back to get your money back, you just prove that you know the secret that one hash gives.
Yeah, it's
This
the
is
same. So
system.
in this case, this C will be a secret, right?
Yes,
But-
this S.
Yeah, it's
will be
okay. Yeah,
secret,
it's
yes.
your
The
secret.
commitment, of course, is public and is added.
Yeah, so my question is like, how do you know? So your contract verifies this data like using some proof verifier, right?
Yes, exactly.
But how do you know the same input is used when you calculated this hash?
So
To contract, you're only providing this C, right?
So in the verifier, you can verify that all of this has been computed correctly with the attestation.
So you have two
And
proofs.
there's only one proof. You come with your attestation, your secret and everything, and your attestation. And one of the public outputs of the contract is this commitment
But when you mean data is
of the circuit. One of the public output of the circuit is this commitment. And data is like the hash of all of the data you might want to reveal. So for instance, in our case with proof of passport, like the circuit will take all of your passport data, it will take like the things that you might want to reveal, hash it, put it together with attestation ID, which is a public input because it has to be verified in the contract that you like register with this like attestation ID, which is public. This secret is of course secret. One of the outputs, public outputs of the circuit is the commitment, and the commitment is added to the tree.
Right. This part is clear. Like, and then the circuit also give a proof of adding C, so the Merkle proof of C, right?
So
And the new Merkle route.
when it's put on chain, yes, you register C, and so it updates the tree, and now there is a new.
Oh, that's happening on chain.
Yeah, you don't. Right now, there's no Merkle inclusion proof. You're just.
Oh, so this is the registration.
This is the registration, yeah. So this is registration, and then we'll do usage. It's just like quite similar to what you described.
Yeah.
I guess the only difference is that the commitment is a bit more fixed.
Yeah, but my question is not like when you register, how do you ensure the data is the same? Like the
What do you mean? The data is this data?
you have calculated C from this data
Yes.
and this attestation.
Yeah, this is all. You can do all of that in the circuit. You,
Yes,
you
you
will
can-
do the same thing, by the way.
Yeah,
pretty
yeah,
much.
you can do that in the circuit, but how do you verify on chain using this attestations verifier? Like you are
Oh, like
to
well, you check
verify
with
on
the.
chain, you also need to verify your passport proof on chain.
Oh yeah, yeah, yeah.
You need this data.
Yeah, completely. So,
How do you- yeah, the
so
question is- yeah.
one part of the circuit that I didn't talk about here is like it checks that your passport is correctly signed by the authority.
So you have both in one circuit.
Yes.
Okay, so this is the problem we have. Like, if you want to make it more generic, then you have to verify the proof of passport or Aadhaar or whatever, and then do this and add to the tree.
So every protocol that will want to join your system will have like to then update their circuits to have this kind of commitment also.
Yes.
While
Oh, okay.
you could have like a setup where it's the responsibility of the proof issuer to set his rules. See what I mean?
Well, the proof
Yeah,
issuer,
so
I'm not sure
the blocker for us was like now you're doing the proof of password and this in one circuit, right? But
Yes.
if you want to make it modular, you cannot do that. So like in this proof, you have to take another proof and then verify that in circuit, which is not possible. So how would you do? Okay, so in this case, if other wants to support this one, the other's output has to be this, right? Like
Yes.
you have to do some extra stuff on other.
Yeah, you have to change the circuit. That's true.
And
Because if
then-
you don't change the circuit, it's just a different.
Okay, you.
No, because that's why it's there is a slight difference. Is that so to just compare? So that's an ID. But if you don't want like to require all the protocols to change their circuits and add this feature to their protocol
Yeah.
because it's already audited and stuff.
Yeah.
So to prevent from this, what we thought about is like more like you have one Merkle tree, and each Merkle tree is like linked to one protocol or one statement of the protocol. In our example, maybe we have like one tree for the person above 18, for example. And so then, if I want to join like one of this protocol in this case, I will just have to up like my smart contract, my group maintainer, and add my set of rules in the add method. So I will customize my add method and say, oh, okay, by the way, etc. And so it's the responsibility of the new protocol that I want to integrate the whole system to say, oh, okay, by the way, this is how I verify the identity, and here is the unique value I put at the end of the process. Or if I don't have any unique value, I don't have one, and I specify it.
And so people just have to register once or once for every protocol because different.
No, once for every protocol. Yeah, you will have to generate proof like for example, if you want like to prove that you have a YouTube account, you will have like to use a ZK email secrets to prove you have a YouTube account. But in this case, like you can it's more modular because like any new like prover can like say, oh, okay, by the way, this is my verifier. I want to add it to the system, and yeah. And also in this case, you can like just maintain like publicly, because there is another question is how you maintain the attestation ID. And in this case, you can have like just a public registry, like where you don't enforce like the legit protocols, but you can just have a list saying, oh, okay, by the way, proof of a French ID is this address, or proof of Aadhaar is this address, etc. So I wanna because I think that what could be interesting is that I want to understand this, because in our system we have a slight problem is that if you have like one Merkle tree for each protocol, in this case when you will reveal identity, you will also reveal like some stuff that you committed like while generating the proof. So that's why I'm interested into like, the whole Merkle tree data.
It's similar in some sense because like having one big Merkle tree is only useful when you want combinations. If like one application only accepts, for instance, people that have an Aadhaar, then they are going to prove that they have a valid Aadhaar in the tree, but it's not going to give them a bigger anonymity set than if it was separate trees, because you can already see from the verifiers on chain like the number of people that registered Aadhaar compared to other sources. I don't know if it's clear,
but you
but
still have the call data of the smart contract, so I can also retrieve the data of all the people, all the ETH addresses that committed like Aadhaar proof or proof of passport proof, etc.
yeah.
So that's the same problem.
It doesn't like, basically having one big tree doesn't help if an application only wants to verify only one thing. Having a big tree only helps if, like, for instance, your Gitcoin passport and you want to do a score with a bunch of different proofs. Now you can, like, as a user, come and say, I have those attestation, it gives this score, and not reveal which ones.
Yeah, but you can do it with semaphore inclusion proofs also, because they are not disclosing like the underlying identity, just the.
Yeah, but if it's different trees, then you can't compute a score, because at one point you're going to have to make things public before you link them.
One big tree, I think. So there are like two approaches. One is like join multiple groups after verifying your identity, and this is possible. The only problem is you have multiple groups, and then every time you add attributes from a one proof, it's all linked to one semaphore public key, semaphore identity commitment. So if some person is able to point you by one attribute, they will learn all your other attributes. So this problem is also there.
Yeah, I think it's the case in both.
Yeah, that's okay, I think. But the main problem is like you will have to do multiple proofs. The another solution we discussed is like you have a tree like this for one person, one tree for one person, for example.
One tree for one person.
Yeah, and then in like you have some like say 32 nodes, and in each of them you save your attributes like your state, your age, and anything you want.
Yeah.
And then you have a hash, and this is, and next time you want to prove, like in a circuit, it takes the old Merkle root and the new Merkle root, and it has a state translation function, which basically means you have changed, you have the data, updated the data here and here,
Yeah, okay.
and this is the new root.
And the circuit also checks the
So the problem is it has to verify
destination.
these attributes came from another proof.
Yeah.
So this is the blocker.
Yeah, like the question is how do you link the two proofs, right?
Yes, yes.
Yeah. I think you should just do all in one. Like you prove your ADA,
Yeah.
and the same proof you update your
So
tree or
then it's not very modular. But in the other,
Well,
like you can do something similar on chain.
like it can
So
be
you can
more
build this
modular.
tree on chain, like you pass the proof and build this on chain. So to hide it, we will have to go with some privacy blockchain like Aztec.
No. What do you wanna hide?
Because if you do it normally, like if this full tree lives on chain, then like anybody can see your full data, right?
Yeah, you're never putting your actual data on chain, right? You're just putting hashes.
Yeah, in now like with the state translation thing I explained, yes. But to do that, you have to verify one proof inside another. So this is difficult.
Not one proof inside another, just you have a big circuit. You don't do recursive proofs. You're just checking like the ADA and in the same circuit you update this.
Yeah, but then you have to do the same thing for every circuit, right? Like every.
Yes, in every verification circuit you also
Yeah.
have. But this
Maybe
is,
that's not too bad. I don't know.
To be honest, I didn't quite understand the retrieval method of the blockchain.
I think in any of those systems, we won't be able to just take circuits that already exist. We'll have to update them at one point, whether it be to add the semaphore commitment, whether it be to add the totem commitment, which is just a semaphore commitment with a bit more data.
So I can.
But
So
why?
let's say if let's say all Aadhaar and passport, it's not a proof. It was like a plain signature, for example. Then you can have like one signature check in the circuit, and then you can do it like with any ID system. But that's not the case, right? So if you can make something like that, then it's possible.
Can you?
Like if you can verify one growth 16 proof inside another circuit.
No. You don't need recursive proofs anywhere. Why would you want recursive proofs?
To do this, so yeah, here what I'm trying to do is like I have like 18 on my age field.
Oh yeah, so
But I'm not revealing this data. I'm just telling the blockchain, this is my old Merkle root, and this is my new Merkle root, and here is the proof.
It's in the case in which each person has his own Merkle root, right?
Yeah. And if I do that, I can put any data I want. But the circuit should also constrain that this data is attested by someone, and this attestation in our case is another proof. It's not a signature.
Oh, it's another proof, it's not the signature. Oh yeah, then you would have to do recursive proofs. But you don't want to do that.
Yeah.
It's just too complex. You just want one circuit.
But like if you are updating circuits like you do in Totem, I think this data structure is also good. What we are doing here is like we have fixed index for each identity attributes, and you are proving that the value at index 3, which is for age, is 20.
Yeah.
And then to prove that.
I never thought
But
about
I guess
this,
that's another level of granularity, and to me, like just for a proof of concept, like having like all the protocols change their circuits and discuss to all the protocol to.
But there is no protocol to discuss with because we are the only ones doing those things.
Oh yeah. But in this case, so you cannot aggregate other.
You have to have verification circuits, yes, that comply with this format.
Yeah.
No, that
But like,
here is
I mean,
you don't need multiple proof.
Yeah.
In any case, it's going to be the case in any way. Like any case, like for instance, you check ADA, you're doing the circuits like. It's just always going to be.
From like for example, if we want to integrate like proof of passport, it's quite easy for us because we just have like to up like a new semaphore maintainer contract, and then just add your verifier method and add people to the group this way.
Yeah, but the proof of passport circuit is going to have to include this, right?
No. It's just we just need the August 16 solidity verifier. That's it.
And opposite for like semaphore function, you can just include the
So you have like an identity and you can join the group. And to join the group, you just show the proof of passport.
What do I do with my verifier contract that I generation of our circuits? How do we implement it inside semaphore?
Oh, it's quite easy. Like you just have like the Go16, for example, the Go16 solidity verifier that you generate with SAP.js. You just have it. You have an address and you just.
Okay, so semaphore is really modular about verifier contract that you can implement.
I mean, smart contract. So the add method you can customize it. You can put any rules that you want.
So in semaphore, to add a member to the group, you don't need anything. You can add anybody.
You have to input a secret, right?
No, you basically give a public and it gets added. So before we do that, we verify this and then add you to the right groups.
Yeah, but like for instance, in the naive, normal like proof of passport circuit that just verifies the passport, there would not even be a maker tree, a public key or anything linked to semaphore. So
you don't. So you have. So it's not required like for the basic operation, but to prevent front running, do you have like a signal input in your? Yeah. So the signal could be like the semaphore public key. And then it's basically when you are generating proof of password, you are committing to that public key semaphore. And then in the contract it will verify the proof of password and add you to the group.
Yeah, but then you don't have a secret that you input at any point.
You don't need like that. Okay,
so how do you prove that?
This app, like this identity aggregator or the SSO app, for each user when they onboard, they will create a private key.
Okay, but then the private key you have to register it in the tree, right?
No, the public key you have to register, but you will do that along with your.
It's an identity.
So you prove your password.
Okay,
you
yeah.
register your public key. So there will be multiple trees. That's the only problem here. Like you will have
and also
one tree per ID group.
And the thing with that is that how can you prove do the totem ID with like proving generate a ZK proof that you have the same name over your passport than your ID card?
We can't do that.
Yeah, this is maybe the totem thing.
But you can prove that the semaphore public key is saying in like you can just check. But yeah, like if I add my other and his passport in one account, it won't stop. So, but in this model we can do that. But this is the other approach, where you have like one paper user and then the intent is to search for the identity key. So if I already have name and then the circuit can prevent, I don't know, maybe like if the value changes, you can either prevent or you can use a new value.
And so you don't have selective disclosure. I mean, how do you do selective disclosure in this?
So in this case, that's the main. What do you mean by selective disclosure?
Like for instance, selectively disclosing my edge.
I think you need to have a
tree. That's already a feature in our protocol, but that's the problem. That's the missing piece that we need to.
Yeah. So the problem here is if you, okay, so you need a tree for each like group. So for example, if you want to prove that you are a Go18, that's like one group. You can be added. But you want to prove your age, then each age needs a group.
Each age is a group?
Should be a group, like if you want to reveal the exact value.
No, you can just have like, oh yeah, because you can't do selective disclosure, right?
No, like so for example, if you are, let's take state, and you have like 30 states in India, and then you have 30 groups, and then you join the group of your state, and then if you go inclusion in that group, it's basically selective disclosure.
Yeah.
But like,
I mean, you want, yeah, you.
depends on the data. Like we have pin code, it's like a lot,
Yeah.
and then if you do age, it's a lot.
Okay.
So
You definitely want to.
you'll end up having multiple. So if the application want many specific requirements for you to use that application, you'll have to create that many membership groups.
Yeah, you definitely want to put attributes like states of ADA or something in the commitment so that you can reveal them, not do a bunch of different things for each one.
But like
again, your passport.
no, the commitment is not something you can generate.
No, because it's already.
Yeah, it's,
The commitment is hash of name application.
yeah, but this is the problem. This is why totem.
Yeah,
Because now you
yeah,
can
I
add
agree.
new
Like
things. Yeah.
that's the downside. But like here, you have to change the.
Yeah, but I mean,
disclosure.
I think we are so early and all those implementations are still in
I think
the
like
process of being made, so we just.
now that I think about it, like changing the circuit is okay. Like you import that, you do some extra stuff, right?
Yeah, I think you always
have some ideas, but
pretty much have to change the thing. But yeah, you're right that
No, if
when
you're
you don't
doing,
have to change it if you use like the commitment, but then you have to have the circuit having a commitment. So for
but
instance,
if you're changing the circuit, I think this data structure is better.
It's not.
If you're changing the circuit, I think
But we have like
this
My
data
contribution
structure
was
is
adding that sign to this.
probably better.
Passport.
yeah,
I made
Uh,
signs in
The thing is,
Istanbul because it's really cheap.
I mean, it could be same. So how do you prove? So I don't know how the reveal works here. How do you reveal your? So in this case, this data is the same thing, like as it is extracted from the source, right?
yeah.
Yeah, but like if you want to reveal some index which correspond to age, is some value, then how do you do that?
So then
You need a whole new circuit for that, right?
you can have one circuit that supports a whole bunch of disclosure, and this is what we have with proof of passport. So basically what we have is a bitmap over all of this, and you just say which bits you want to reveal. So like I want to reveal the countries, it's like FRA for France.
Yeah, I got it. Like,
and then I don't
so
want.
this also has to be like
And this
then
is the-
customized for like each of the
Yes,
yeah. So in this
this
case,
is all custom circuits.
yeah.
Very custom.
I think maybe if you are down to change the circuit to a bit or like create a subset of each circuit, then maybe we can go with something like this.
This is
And then the
very, I guess,
for
custom.
example, like the smart contract can verify the proof and then add it to the right indices.
Add you to the what?
Like if you are revealing the other data
Yeah.
in the proof, for example, if the second public output is age, then like you can check that here.
Yeah. Well, for instance, the way we do it right now is that like you have this bitmap that you pass as a public input, and in the circuit is going to only reveal, it's doing a XORing or something, it's only revealing the attributes that are here, and then we pass the outputs into a human readable format, like, oh, the country was revealed, but this was not revealed, and so then you can have all of this on chain or in the contract.
I think even the bitmap can be private.
The bitmap can be private, but there's no point. You can also put it public.
Yeah, because if you put it
So,
private, you don't know like at which index
Yeah.
you added the data.
Yeah, I think
No,
it's
but
just
like
easier.
if some of your reveal data is boolean value, then
Yeah, you want
the
to
result
put
will
it
be false,
public, I think.
irrespective of.
Yeah, you want to put it public.
Because in the way we are using it, we don't need it to be public, but
Yeah, but I mean, yeah, if it's boolean, yeah, you want to
No,
see
we,
if it's
we have
false
this,
or yeah.
this bug in here that needs to be fixed.
Mm.
Or like
So-
change boolean to
So,
something
so
else.
what is the conclusion? Because I still don't I still
Yeah,
don't understand
yeah.
the method too, like about how to retrieve data and stuff
Okay, so
from this scheme. Yeah.
okay, so maybe first I can just show how you do simple selective disclosure with just one, and then the like the total special thing of doing like crazy multiple selective disclosure in one or something. So the way you just do selective disclosure, it's pretty like similar to what we do right now in passports. Is that one, in the circuit you prove that you have a valid commitment in this tree, and two, from this commitment you also give the pre-image, which is this. So you have the secret, so you are a valid possessor of this attestation. The attestation ID is going to be public, and it shows that you have a passport and you're not trying to cheat or something. And then in the data, you also like have to input this, and you can just reveal effectively something with the bitmap. Is this clear or not?
Yeah, just for
Yeah, so this is like normal selective disclosure of one thing. Now, how do you do, for instance, matching?
in this case, how does which index the one name starts, for example? Is it always fixed?
Yeah, for instance, it's always fixed. It's like in the MRZ, you have specific fields for everything.
Like, is there something like the name will take 20?
Yeah, exactly. It's
Okay.
like indexes that are hard coded.
Then it's fine.
Yeah.
Yeah, for other.
And then, okay, you will see if you don't like custom things, it's going to be very custom now. It's like, so basically, if you want to, let's say that you want to prove that you have an ID card and a passport with the same name, for instance. If you have separate trees or something, you're going to, at one point, have to output things that are going to be public and that are going to dox things about you. Or you can put salts, but if you do salts, like all of the secrets have to like support it. Well, basically we're going to have salts too. So you can like, okay, what's the best example? The simplest example, like.
For combination.
Yeah, for the combination. So
Education degree with your passport.
yeah, like for instance, you have the same name between your passport and your ID card. So basically, what you can do is a proof that contains two inclusion proofs. So you prove that you have two valid leaves, and you like match things between them. And how do you do that? You have to have circuits that do the matching, and basically the idea is that like you have like two inclusion proofs, and they are going to output linking commitments, and linking commitments are like salted commitments to the attributes that you can match, so like of the data basically, and then you can like prove that you know this salt and that those different things match. So if it's just like an equality check on the names, for instance, you can do it, but if it's like regexes or more complex things, you can also have that in circuits. So you always have to have like circuits that do the matching for things that you want to keep private. But basically now, if you have like a circuit that computes scores or something, you can like have it without having to disclose which attestations you had. Okay, I don't know if it's very clear. Maybe I'll just write what the linking commitment is. So it's very similar to. And then, so it's. So basically what this commitment is for is basically, so it's quite similar to this one. The only basically difference is that instead of having your secret, you put a salt, a one-time salt that you are going to use just once to link those different attestations, and then to do a new proof, which is like the linking proof, that will like in which the salt will be a private input and the circuit will like match attributes.
How do you commit to the salt? So it's just a value that I need to store somewhere?
Yeah, like the salt is one of the, yeah, you store it somewhere, and it's a one-time salt, so basically you'll do it like, you'll generate it, do your proofs that the things match, use it, and discard the salt. You don't have to keep it.
What is preventing me to generate as much salt as I want?
You can generate as much salt as you want and do as many of those inclusion proofs as you want.
Okay. So
yeah.
there is no way to nullify like a user, for example?
Yes, you can. You have to nullify actions, and this you do it in the same way that Semaphore does it, which is how the semaphore nullify like actions. Like for instance, when you vote, you publicly store the hash of the group ID or like the action ID and the secret of the person.
Nullifier is hash of scope, comma your.
Yeah, but that's the unifier of the identity, but nothing prevents me like to generate
Yeah,
as much salt
here
as
is
I
not
wanted.
solved.
Yeah.
So here, like it works if there is no incentive in user being like that. But like you also want civil resistance, right?
No, you can have civil resistance with that.
Because I can either like generate as much semaphore identity as I wanted.
Also, one problem.
Here you have a nullifier, and you can. So I can maybe go in.
But it's the same McCoy, right? It's not two.
It's the same McCoy, but there are two types of nullifiers. There are nullifiers, but I think it's just similar for you. There are the nullifier for when you register to make sure that you don't register multiple times with one attestation, and then you have nullifiers for actions to make sure that you don't vote multiple times.
So this has to be unified. That's what.
Yes.
Yes,
So
you can just have at the output of the second circuit.
No,
as
not
input, you
unique.
can put like an
One
action
user
ID.
shouldn't be able to create two nullifiers in this one.
yes, definitely. And so the nullifier for the attestation is like, well, it depends on the attestation, but for instance, for you it's this, for us, for right now it's hash of the passport signature. And the nullifier for the action is the same as semaphore, it's h of s scope. It's S is like the secret. I didn't know in semaphore it was like public keys now or something, but
So the like the public key of this secret is basically the C. In semaphore you cannot set the leaf to some arbitrary value. It has to be the hash of the public key.
yeah, well, in this case, I think it could be done similarly. We could adapt this to semaphore, but basically, to make sure that so let's say you are on an application and you come and you have this action which is doing a vote in an election, you can be sure that people are nullified and can only do it once because so the scope is like I call it action ID, but it's scope in semaphore. So let's say scope. The scope will be hashed with the person's secrets, and you can check that the person's secret is true when you do the inclusion check. And basically, like, it kind of makes things more complicated on the end. This can also, I mean, it does not have to be just like when you want to actually apply it, you have to have like secrets that do linking and everything. But to me, it's like the only way to match attributes without disclosing anything.
Yeah, but just to me, it's not complicated. This is like I still don't understand how do you match common attributes from.
I also have one. So like what you're doing is like you're taking this data and another data here, and then saying at some index of this data the values are same as the other index in that data.
Yes. Okay. So let's say that I want to use it for the use case of proving that I have the same name across passport and ID card. So now I'm doing my inclusion proof that proves that I have two of them. It's outputting those two linking commitments, which is the one for the passport and the one for the ID card. And now those are public. But it's fine that they are public because they are sorted.
Yeah.
And now I can do this third proof, like second did the action, but third it will also count as registration, in which I prove that I use the same salt for both. There's no point in using different salts for both. You just use the same. If you don't, you're not going to be able to link them. And in the proof, I do matching between the data, so it can just be an equality check, or it can be some crazy regexes in which like I extract the name or something, or it can be just like range checks to show that I am above some age, or it can be a score calculation. So for the score calculation, maybe you don't even care about the data, you just check attestation ID, and in the circuit you have like the salt.
Right. But how do you know? How does the circuit ensures the name, for example, is on the right index in both the data?
So the like primitive way of doing it is checking with hard-coded indexes, but in practice, it's a bit tricky because most of the time it's not going to be exactly the same name. Like,
yeah, even the index change, for example, in other the indices are dynamic.
yeah, so you need regexes in practice.
Which also means that in this case, then for each thing you want to equate,
Yeah.
or like greater than less than, you need additional separate circuits, custom
Yeah,
circuits.
yeah,
It seems to be like a circuit mess.
yeah. But I mean,
That's not
is there any
feasible.
other way?
No, I mean,
Yeah,
I don't have any ideas. I'm just
it's a mess on the application side because as an application you have to have circuits that do the matching. Yeah, I mean in practice, like the developers of this would do
Yeah.
those circuits in practice, but like theoretically, if you are a new
So-
app that comes,
yeah, when I also think like this and go into some steps like this, and then realize, okay, this require more circuits, and I drop the idea. But like,
Yeah,
I like
I mean,
your way of
yeah.
point thought as well.
I mean, I'm just
If you
thinking
do
how.
the circuits, we can solve.
Yeah, I'm just thinking how can we like.
I mean, there is
Because
no.
basically, I guess
to
my
me,
general
to me,
thesis-
that's not. I mean, we had the discussion yesterday. That's not something that is really required. Like to have to prove that you have matching fields from different identity sources. That's something that
But,
you can get rid of because
right.
you can just at the consuming application level, you can just enforce like one kind of identity. Say, okay, I just want like driving license, for example.
Yeah, but then
and
you
plus-
exclude the people that don't have it.
Yeah, so you can choose and maybe commit to the type of document. But this works. So first, you have like a lot of assumption in terms of, okay, so is it feasible? We don't know. And
It's
plus,
feasible. It's just a bit complex.
what do you output from this? Like, is it like a way to nullify like all these proofs? So because I guess that the goal of this is like nullify someone, like being able to say, okay, so if I want civil resistance, I want one person that have like 4 signed document, a passport, an ID, a driving license, to have like one unique identifier that I can use to my application and say, oh, okay, this identifier is on one person. I know it. You cannot use other signed documents.
Yeah, it's more like as an application you can register this linking circuit and only accept people that can match your requirements. So for instance, if the requirement is like 3 of those 4 sources, then you can have that. And because you have one big tree on top, the people do not even have to disclose which of the 3 of the 4 they have, right?
Yeah, but what prevents me like to? So okay, so let's say I show 3 out of 4. What prevents me to check this like 1,000 times?
Because it's going to be nullified here with your secret, which is like unique, and the scope.
No, here also you have a nullifier, I think, because this can act as a nullifier, right?
This does not have to act as a nullifier. When you do those proofs, those inclusion proofs, you output the nullifiers.
Oh yeah.
You output just one nullifier for the whole action. And then all of this does not have to be nullified because you just nullified the only things that are unique. So the scope of the action and the secret. Like for instance, if it's a vote, you just have to nullify it once, just by showing that you have like all the valid things to do the vote. If you don't have it, the circuits won't pass.
Yeah, but that's how you get
So
validated,
that's
but not
for
how you
voting,
get
right? I was
nullified.
talking about like proving that you are saying, but like maybe that's not even a requirement. You don't need to prove that you have same name in multiple documents.
Yeah.
Right?
Yeah, so like
Name is something you probably don't even reveal. I mean,
yeah, this does not reveal the name. You don't want to reveal the name. But
yeah, but you also. So what's the goal of proving? Oh, so you're basically proving you have multiple documents with your
yeah,
name.
so the general thesis of why doing all of this is basically to say that, and to be honest, it's a Nobel question. Like it's probably the first thing we should think about. It's like if you want to have applications that like are inclusive, can you really do it with like one attestation at a time? Or can't you do a more general system in which, because basically, like for instance, if you want like an airdrop or a website that gates to like real people, and you only gate to like one specific attestation, then maybe I can just take the passports for my parents and for my friends and everything. But if I have to match different like sources of identity, and there are like, let's say there are like 10 or 15 different possible. And to be like credible, you have to have like 3 or 4 of them. You can also check matching between them. Then it becomes like harder to cheat. So if you don't care that much for a specific vote, let's say you can just like accept just one, and you will miss all the people that don't have it, or accept multiple of them, and then the people that have multiple of them will be able to vote multiple times. But if you want some kind of threshold or some kind of more general thing that's like can have like either a score or different levels, you might want to.
So yeah, the goal is more of civil resistance, right?
I think it's more civil resistance. If you
we were not thinking in that direction.
What?
Like just like improving the civil resistance. Like in our case, we are assuming like even if you prove like other from like one source, that's sufficient.
Yeah.
But like the goal is to prove your other attributes much more easily.
Yeah, I mean, if you have a specific use case like doing a vote with the people that have ADA, you don't need any of this. You can just do what you're doing right now.
Yeah, so like one example is like, okay, you want a voting app, but only this is not voting app for the whole entire user base or entire country. It's only for like one state or one group or like a specific people with specific attributes.
Yeah.
For such kind of apps.
For those kind of apps, you can.
Yeah,
you
that's
don't
what
even
we're
have to
trying
have aggregation. You
to
can just
yeah.
check ADA and check the specific region in each.
Yeah, but like these attributes could be coming from multiple sources. And like
it's
the
good.
goal is to have like
Yeah.
a unified way for
That's good.
like application builders to just point to one place and get the requirements they want.
Yeah, and plus to me, like it's the whole idea about aggregation that is not to me like something that is really required. Like it's cool, yes, but to me like, it's like a bit overkill, like to just have like a complex system that you don't know exactly, or maybe like will just kill your UX because it's too complicated to like what you gain from it is to me like not clear, and because again, as I said, you can enforce like the data point that you want to verify, and just be sure that the person is like actually a person, and that's it.
But yeah, it's also hard to get multiple dogs with same name, right? Or is it easier? Like the full name.
Yeah, I mean.
And the plus if it's
No,
just
but you got the birth date. I think the birth date is really
You can have
easy to
process,
extract.
you can match emails.
Yeah, but like no, like do you have an email with date of birth and the full name?
I have one,
like
yes.
from the government. Oh, okay.
But like, I mean, I think it's very tricky to put that in prod because you need circuits for every type of email.
Yeah.
So for matching between emails, it's like a bit technical.
No, but like if you have one email from one government source, that's enough. And
yeah, but you need to have a different ZK regex circuits to extract it.
yes, like one for one email.
Yeah, for every email template.
Yeah, but like you don't need a lot of email templates, right? The goal is like one password,
Yeah.
one email, and one maybe a resident ID, one license, something like that.
Yeah, but for instance, you need an email template for each like country, let's say. If you
So,
need a,
yeah, that.
like it's tricky.
Right, so it's more on improving your civil resistance score, but also assuming that like you're assuming like if you can get your parents' passport, but you cannot get their emails.
Yeah, the idea is that like if you can like steal everything from someone, yeah, you can try to create multiple identities, but just the cost is higher and it's more technical and more complex. Like because if on any of those things on which there's one unique source, you can try to buy at scale the source. If you have to have matching, it
yeah,
also
if there is a
becomes.
data leak, then yes, in that case it's.
If there's a data leak, if you
Yeah,
have to have
like
matching.
anyway, like the goal I think is different.
Yeah, I mean, definitely, this is what I was like saying in the beginning. It's quite different. I think what you guys are doing is just like good in itself and pretty similar to what we are doing with proof of passports this month.
Yeah.
Just the difference is that you have this like unified UI, which I think is nice.
Yeah, we don't have. We're trying to.
Yeah, and plus is that we think that if it's good enough, it could be like integrated by other protocols. So
Yeah.
the goal is It's just that we don't just want to use it for another, because if we have like to build an SSO service for another, maybe we'll choose like another architecture. But what we wanted like to try this month is more like having something like where you can aggregate multiple proofs. So you have like plenty of applications that try that. We know Sysmo, we know like the Zupas. So it's just that it's a different approach, because in both Sysmo and Zupas they need like a centralized server. So we just want
Polygon ID and Sysmo.
Polygon ID is also like a centralized server.
Yeah, in both Polygon ID and Sysmo, the issuer is like a server, like issuing you with a signature.
And Zupas,
and since the signature is standard, then you can prove it in a circuit.
Zupas is also centralized in a way, because if you want like to add your proof,
Zupas is not even in this kind of app, right?
It's the
just
same.
like
It's the same setup. It's like basically
Not
it's
really,
like
there
one
is no-
setup for identity, and then you add proofs on top of that.
No, it's not like a proof is on top of your identity. It's just like there is a proof, and in local storage it saves all the proof, and whenever you want it, you'll display it here.
Yeah, but
That's what I understood.
your account is like a semaphore identity, but
No, but that's like one kind of proof they did for.
in Zupas.
Yeah, that's one kind of proof they did for the Zuzelu.
Okay, I thought that when you register with email, like you have like a link between your email and you have like one semaphore.
Yeah, that is
identity
true,
underlying.
and that's used for the Zuzelu. So that's one proof. Like, but you can have like use any number of proofs. So they build this for like displaying their proof and their proof, but you can store any proof. But yeah, like there is no link between each PCDs you store. They are like separate things.
Yeah, but it's gonna be the same case. It's just
Not
that
really. In our case, it's the one semaphore ID that's joining multiple groups.
Yeah, but I mean, like, if, for example, you can add proofs and will not verify that there is a link between proofs. We are just, for example,
no, we will have to, because the applications, when they receive proofs, they need to make sure the nullifier in each proof is same.
we don't need that. Like, it depends.
Otherwise,
on what
like I can give you my proof, and then you can.
Yeah, but what is the incentive mechanism for you to give you my
Incentive,
proof?
but like it's something we can
Yeah,
lock
so
in the
that's-
protocol very easily.
Yeah, but I mean, there is no way to
I don't know.
get it, because
It
there is no
depends on
logic.
the application.
It's like I don't know, like I will give you my house or so, like in my car.
You can sell your identity too.
You can sell it, and it's even greater if it's create a market. Then fuck it, let's go.
Market for other.
Let's build
That's
that
what the
marketplace.
people did with the.
Do you want to discuss how that marketplace will work without revealing who the seller is?
Verka
do it.
trees. I think we need Verka trees for the marketplace.
I think we need a layer too.
yeah. We need a settlement layer for all these proofs.
Yeah. Look, put this in a L2
And do a token.
and do a token.
Yeah, I mean, admittedly, totem is only useful when you want to do matching.
No, but that use case can, like, it also has a
I'm just wondering, like, it's the question
But
that
again,
Yannis
why-
asked, like, where do you need matching, like, because you can do basically a better kind of Gitcoin passport with that.
So in Gitcoin passport, like when you get at like what's it called, attributes from multiple source.
Steps.
Yes, stamps. Yeah. Do they check it's does the stamp have some sort of
They don't check similarities between them.
To
Now
me-
you can do it.
To me, like it's the same as so how the web works today. So the ownership of your account is that you know the login of your account, and so if you know the login and how to generate proof from multiple accounts, let's say YouTube, Discord, etc., it's hard enough. You don't need to exactly know that you registered this Discord account or you have like this account that match names and stuff. So that's cool, but
Yeah.
to me it's not like a security property that is needed.
Well, I guess that depends the level of civil resistance you want.
But
Like if
even
you want
for-
but
armed
still
civil resistance.
Still in Totem, you cannot prevent one person like having two accounts for passport and the other ID, right?
You can, but if the threshold is high enough, it's just going to be harder.
Yeah, but
Yeah.
what I want to say is that if you have like one kind of proof of identity, in this case, like for example passport, for me it's even like already like very hard. And then you have like I don't know, like 2 or 3 proof that you have like other activities on other stuff, and you are an owner of an account of other account where you have activities, it's enough.
Well, if you can't
Because
match
if you
them,
have-
then it's pretty much the same thing as just having to have multiple passports, because creating accounts on Discord or something is just easy to do at scale.
Yeah, but the strong proof is like the proof of passport.
Yeah, but in this case, you just stay with the passports. You don't even have to add others if you can't match them.
Okay, that's even perfect. So you don't need to add.
Well,
aggregate
yeah,
others.
but if it's just the passports, you don't like. You can buy some, right? It's harder if you have to match attributes between multiple sources.
But
I mean, it's like good enough passport for some things, but if you want like better civil resistance, like
But what is better? What is not civil resistant in the way you're proving passports?
because like we want to get to all kind of security, and this is not doable with passports alone.
Yeah, but that's fine.
I mean, it's fine if you don't care about strong civil resistance.
It depends
You don't need it.
what you call civil resistance and for what use case. If it, for example, it's like just a...
Or if it's for voting, for instance.
Yeah, so...
You can also assume that if you already have a passport, if someone obtains someone else's passport, they can obtain like other dogs.
You
Passport
still
is
have
like the most secure one, right?
Yeah, because
They can obtain what?
Like if the user already proved passport, then all other proofs are less valuable than the passport proof.
Yeah, but if you have to get all of them, it's really complex technically. Like for instance, I couldn't just take your passport and do a proof. I would have to get everything from you, and it would take like time with you to actually do all those things.
Only if the application is requiring everything, right?
Yeah.
If they just want to.
If
then-
they just want to, then we just have to do the two things.
Yeah, but yeah.
It's
But
just-
my
it's
point
just
is
a
like
question
if
of
you
like-
can manage to get the passport, then the other one might be much more easier.
Yeah.
And
But technically, like it's just more complex to do. Yeah. But it's also your point is, I mean, in some sense, it's also more complex for the users, and it's kind of bad that users have to put multiple proofs. Maybe it's just simpler to keep just one.
But to me, I'm not bullish on multiple proof of identity. To me, one is enough, because when you say like the statement to say that proof of passport is not civil resistant enough, to me, I'm not agree, because you are limited by the total number, and if you add a selective disclosure to it and check age above 18, so the total amount of vote that you can compute is the total number of signed passport out in the wild. So that's already like quite a nice property to only enable this kind of document. So one signing document is one vote. So and you can't cheat that. So okay, if I take like the passport of my mother and father and my sister and I take their vote, okay, that's up to me, and it's pretty bad that I'm doing that, but I can do it anyway, and it's not a problem.
Yeah, but the
It's
problem
still
is
one human, one
if you
vote.
want to manage a shadow election, for example, the state that can forge passports and vote inside the election.
That is
Yeah, but that's really
Okay, that's a use case. Yeah.
That's I mean, if you want like to
No,
to solve like some
Yeah, it's true that if you do
some
like aggregation with a score, then any of the particular sources of identity, they cannot cheat easily anymore, because they would
Yeah.
have to collude with the others to like forge.
Yeah, but the country that can do one can do all many. But yes, yeah, I agree. That's.
I mean,
a good
I
point.
guess like my guess is that it might be useful for something like Gitcoin passports, and for things like quadratic funding, in which you want like.
No, so if someone is intentionally giving like the parents example,
Yeah.
you can get all of the other requirements as well from your parents if you're getting the passport, right? But the example he said is good. Like if you have to manipulate, then if the government is if the issuer of that signature is like issuing fake just for this vote, then
Yeah.
you'll have to fake from all the source.
Yeah.
But yeah, I mean it depends on the entity. Like the other ministry is sending the emails, they also can do it. Yeah, you'll have to collude with everyone. But again, like if the issuer passport is corrupt, then it might be easier to corrupt other officials.
Yeah, so then like
Yeah,
you break so
yeah.
completely like the trust assumption of the protocol, and then you're like basically it's defeating like the first layer of the.
I mean, you cannot prove that they have only issued like fake passport, but they have not issued fake licenses. It's difficult to prove. What
Yeah,
that
I mean,
means.
if you rely on only like attestations from one government, then of course the government can like forge those attestations.
Yeah,
So it
but-
is like getting built for multiple different like.
But saying that is the so if we go like at the end of the IDs, just so let's drop Anonada and Proof of Passport and just adopt WorldCoin.
Well, not if you can like aggregate them and have like a system in which any of those individual like sources cannot. Basically, you just want to have the system that's not fragile to one like attestor cheating basically. So no, it's not like dropping everything because like if you can aggregate them, then it's way harder to cheat because now you have to like collude with basically like governments would have to collude with all of those different actors to forge.
But it's even like that there is like deals at the geopolitical level. Like if I don't know, like other countries like found that one country forged fake identities, it's like pretty bad actually because otherwise
They are doing it.
what?
They are doing it. They need to do it to forge passport for intelligence, secret agency and stuff like that.
Yeah, they're doing it for.
But we don't know about
for
that.
services.
I don't know about that, but I
They
know
do
that.
it. But it's a minimum level, and so everyone doing it with a small bunch of passports, so that's okay. But
Yeah, I mean, again, like if you assume that those countries cheat, then just relying on only one is just worse.
But in fact, the setup with WorldCoin to prove that you're a human, and then aggregation of other data to prove selective disclosure, whether it be that you're above 18 years old or that you have a specific nationality to vote on something. Yeah, I think it's all the use case, this one.
And it depends, like also like what kind of vote we are talking about.
I mean, I
I
guess
think
you
it's all about civil resistance.
Yeah, but what type of vote? Like how sensitive is it? Like
That yeah, like if we start questioning too deep, then like what's the
No,
real use case of blockchain?
no, because what I mean is that
So
I want to see because I really love these proofs and I just want to see them like in use, you know. And I think that we arrive at a maturity level where it should be already used somewhere.
Yeah.
And it's just that it's powerful enough.
no, the thing is like right now like for most teams the protocol they're working on now they might not know the clear use cases, but it might come at some point.
So for me, it's more like okay, let's find use cases, let's use it, and then see like whatever it's the missing pieces for it to be used at here.
No, but like there is some value on that aspect. Like you will have to collude with multiple issuers to issue fake. But I also think getting this. So you thought of this for other and then some degree, but like how you match. Maybe name alone is not enough. You need name plus TOB, right? So that I think it's hard to find documents that have the same values.
Yeah, and also I think it's
But like it's maybe the Indian case.
it's something that can that is also like very proper to every country, because in France we have like a very simple to do that. It's the data matrix, the 2D doc. So you have like your tax report, you have like your I don't know, your bill, your phone bill. Everything is like signed, CDSA signed.
Yeah.
So basically you can like.
But do you have a unique ID connecting all your?
No, you don't need it. Why do you need it? You just like have like your documents.
Yeah,
and
but
you can generate a proof like of 10 different type of documents, and where one of the main one is like your ID, for example, which is like also
So you
using
have the
data
same
magic.
full name plus same DOP in all of
No,
them?
we don't care. You can do it if
Oh,
you
yeah,
want.
but,
but
okay,
we don't
well,
care.
I'm talking about for total to connect.
I guess maybe one interesting thing would be to match JWTs or after JWTs between multiple accounts and show that they are linked to the same email. Like Google, Facebook, blah blah blah.
But do they include email in the JWT payload?
I think they do sometimes, but not always. I guess you could do multiple ZK email proofs of receiving specific emails to your email. How would that be used?
The question is, how stronger is this? Because even if you have the same email account through different GWTs, I think it's not improving so much the civil resistance.
Well, if you can prove that there is an age, like our accounts are not new.
But do you think we're making some changes to the circuit?
Then,
Another circuit?
Yeah, like
if you can just create a new account on all of those things
then
at the same time and
add this extra thing.
prove it's not good, but if you
create
have
a
to
hash
prove that
and
like
then
the account is like 5 years old or something, then it becomes quite nice.
Yeah, then we can have
And how can
other
you
data
prove that?
structure of
So
One-
I don't think
one
it's in
person.
JWTs the
One
age of the account ever. So
Which has
you have to do it
so
through
the
emails. You can have any email that's
Okay, I see. Because
Ah,
the
you
email
can-
is
it's very limited.
yeah,
You
ZK email prove that like
Why
you
change
got
the
it like 5 years
circuit
ago or
that are
something,
already,
or you send it 5 years ago.
You don't change those circuits.
Oh.
Those circuits will be there close to you import them, and then you do an extra step of it. You like go wrap it. I think.
Oh, it's the same idea as yesterday, verifying Go 16, Go 16.
No, instead of that, we import the circuit and then we output a hash, or like a commitment to the
I
extracted
don't know
data.
in which use case it's useful to have
Aggregation.
Okay, so
in that case.
I see what
with,
you mean. So
what
it's just a-
I
But
mean
we
is
know
that
the
aggregation of passport,
are you happy with
which is a
first our
really
V1 like the
reliable
semaphore idea?
source
Yeah.
with other
Like having
Well,
multiple trays.
really weak.
The problem is you
Yeah,
will
maybe
have
aggregation is
multiple inversion
like
proof.
Yes.
not that.
If the app wants more.
I mean, I guess we should
The second problem is
start
it's
from
very
use
limited
cases
because like
and then like understand
the thing is like it's you
like
cannot do many things
what they
because
need.
the number of groups will expand. For example, you cannot tell your age, but you can only tell it's about 18.
Yeah, and where is the problem?
No problem. I'm just asking like if it is that sufficient or not. Plus, like we discussed, like if you are
because aggregation
if you want
can
to
achieve two
reduce it,
things.
yes,
First one is
so
to
we
reduce
have
the
like
resistance,
Yeah.
which is
But
cool,
like, when
and
you
the
go to
second
other
one
countries,
is
then it's
to
another
accept more documents,
So, like
which is what they are
if you want to pin
interested
code, it's
in.
like
Yeah. I think the
100,000.
only thing which is useful is
Input.
civil
If you want to all the age, then
Yeah, I
it's
think
another
that's
100
really
groups.
cool.
So
Civil
the
resistance.
number of groups will
In
be
which
very high if
case,
you want to do
civil
select
resistance
exposure.
from
But
passports
like if
are
you want
not
to
Well,
do only like a private proof, then that's okay.
that's a good question. Because basically, I guess Totem is the only thing between passports and WorldCoin that fills this kind
Okay,
of gap.
I'll write all this.
Yes.
If you need anything above passports.
But can't we integrate
Because
worldwide?
to me, like,
Yes, but
there
WorldCoin
is,
you have to
stuff
get
like-
scanned, so
They are like this stuff, and they are like what
maybe there's no
what
oh,
Okay,
next
no, let's
year
assume that we
it's
don't
not
need
as
to
easy
make sure the name is
as
same or an.
you do
Our
it
first
somewhere.
assumption is like
was
the
that-
processor of the document
The
is
thing
one
I'm
of.
talking about is
I
that
was more
it's
thinking
more
about like
difficult
this experiment
take
and
a
the
certificate
actual
to get
SSO that we
orbed.
Oh,
we build a
Or
SSO.
to have
How it's gonna be
the four
like a
document
machine
that's
control.
related.
No, the
Because
SSO
it-
user
yeah.
flow will be the
Well,
same in either case.
You need to take your train ticket.
This is what happens underneath, right?
And also maybe you don't trust the WorldCoin people.
So the flow is always like I download one app
Yeah.
or I'll go to the web, I add my
And
user,
I'm just thinking
I add my
like,
password.
what is there between
And whenever
this,
an app wants
like,
something, it
WorldCoin
will direct here, I
passports?
create proof, and I
What
go
could
back
be
and the app
applications
will
that need this,
Yeah,
like
it's just that how
with
to
more
how
civil
to
resistance
handle
than
this
passports?
stuff.
Which is the
Yeah.
because
Like
I'm
selected
interested in
now,
point,
it's not
actually.
because, like,
What's the what?
Which is the thing that why
But
people
the thing is, if you're
They don't like
using
it
like a
because
standard solution, like a
they
polygonal
seem like-
something like that, then we have to solve
I
all
don't know.
of
They,
this.
they think it's
Otherwise, we
tricky
don't
that they
need to
want
do
to
anything. We just do
scan
something
people's irises
that
or
is sufficient
something.
and works for other, and that's it.
Like half people love
Like
Walker and
another
half
for us
people
also,
hate
that's also
Walker.
okay. But like,
Hate Walker.
if you want the big thing, then we have to probably solve
Should
it.
I end the stream now, by the way? Or be like,
Yeah.
Oh yeah, I think
okay, we'll see.
that's it.
Was there
streaming
alpha?
from there, we didn't even know.
I saw that.
No, I told you in the beginning.
No, I saw your lab. That's okay.
Yeah,
No problem.
To be honest,
Okay,
it's
okay.
so shitty
Then they just
UX
telling,
to have
like-
to scan multiple at the